Okay, let's look at prime numbers. So we've looked at factors already, and they're strongly connected to prime numbers. So a little bit of revision of what is a factor. A factor is a number that fits exactly into another number. So if we look at the number 12, we talked before about finding the factor pairs of 12. How many ones go into 12, Mr. Blom?
12.
Then we do how many 2's go into 12? 2, 4, 6,
6.
8, 10, 12 is 6. How many 3's? 3, 6, 9, 12.
And that's 4.
When you get to 1 you've already written, you're done. So we found all 6 factors of 12. 3 factor pairs, 1, 2, 3, and 6 factors altogether, 1, 2, 3, 4, 6, and 12. So that's how we find factors. I'm still going to have to cut now. Let's look at the factors of another number, such as 7. Do my factor pairs of 7. 1, 2. Mr. Blom mentioned this last time. You never actually have to go past halfway because you know you're definitely done. So I'm not going to need more than 4, that's for sure. 1 times 7 is 7. 2, 4, 6, 8. 2 doesn't fit into 7. 3, 6, 9, 12. 3 doesn't fit in. This is not going to work. 4, 8, 12 doesn't work. Mm-hmm. So here we have 2 factors, okay? So there are 2 factors of 7. 2 factors. Now this is where we get to today's lesson, because 2 factors means you are a prime number. It's that simple. A number has to have exactly 2 factors, and then it's a prime number. So 7 gets to be a prime number because it has 2 factors, 1 and 7.
And it's exactly those 2 factors that we said would be the easiest ones to do. We all know that 1 is a factor of every single number, and we know that 7 is the number itself. And always the number itself can go into itself, because 1 is always a multiple of every number.
Next we'll look at the number 5. We do our factors of 5. 1 times, 2 times, 3 times. You don't need to really go past halfway. That's already past halfway. So 1 times 5, of course. Then we do our 2's. 2, 4, 6. Doesn't work. Do our 3's. 3, 6. Too far. Doesn't work. So again, 2 factors. 2 factors means it's a prime number. So 5 is a prime number.
You've done 2 numbers now. Both numbers are odd numbers. Is that the case, that when you get an odd number, you get a prime number?
Well, not every odd number is actually prime. Let's look at 1 then. Mm-hmm. You've said that. Let's look at
maybe number 9?
15 or 9. Let's look at 9. So 9. 1, 2, 3, 4, 5. Let's see. 1 times 9, of course. Then we do our 2's. 2, 4, 6, 8, 10. Doesn't work. 3, 6, 9.
There you go.
3, 6, 9. Yep, 3 times 3 is 9. Now we've got to 3, which we already have, so we are finished. 9 has got 4 factors, so not prime, not prime.
9's got 3 factors.
Oh, of course. Mr. Blum spotted that trick. Yeah, 4 numbers have come.
It's got 2 factor pairs.
2, 3, 4, but because
But
3
is
the
same number, yeah.
That's only 3 factors. Okay, so not all odd numbers are going to be prime numbers.
You can see the thinking though, that 5 is a prime number, 3 is a prime number, 7 is a prime number. All these numbers are odd numbers that seem to be prime. So don't just think because a number is odd, it is a prime number, because there actually is an even number that is a prime number, Mr. Saul.
Yeah, let's look at the factors of 2. So 1 times 2 is 2. Well, we could do 2 times 1, but we've already done it, haven't we? We've already got 2. So as you can see, 2 has 2 factors, 1 and 2. So 2 is a prime number, even though it's even. 2 is the only even prime number.
Children get really argumentative with me about this, because they say, but Mr. Blom, 2 is an even number and doesn't really have the chance to have more than 2 factors. Well, it doesn't matter. By its very definition, a prime number has 2 factors.
Yeah, if any number has exactly 2 factors, it's going to be prime. That's all that matters.
But if there's one number that children think that is usually a prime number that's not, is the number 1.
Let's look at the factors.
I'll show you number 1. Now, number 1 has a factor pair, 1 factor pair. However, if you look at that factor pair, it's itself, which means that it only has one factor. Now, what's the definition of a prime number? A prime number only has how many factors, Mr. Saul?
A prime number has to have two factors.
Two factors. So it doesn't have the criteria needed to be a prime number.
So 1 is not prime. Many people think it is, but 1 is not prime. So what I normally do, and the children in my sets call this the chosen one. 1 is the chosen one. If you've ever watched Star Wars, Obi-Wan Kenobi gets very angry if you think 1 is a prime number.
You are the chosen one!
Because 1 is actually the chosen one, 1 is not prime. 1 is very special when we're talking about prime numbers. So now that we've talked...
So is 1 the Anakin Skywalker of the world? Will it
It's
rebel
the
and become
chosen
Darth
one,
Vader?
yeah, it's the chosen one. I don't know if it doesn't really turn to Darth Vader that
No,
often, but
okay.
it is the chosen one. So the prime numbers we know are 2, 3, 5, 7, 11. A lot of children just learn the first 5. 2, 3, 5, 7, 11. You can see that 2 is the only even prime number.
4 has the number 2 that goes into it. If you look at the number 6, 2 can go into it. So all these even numbers that are larger than 2 have a factor of 2. So those numbers will always have at least 3 factors.
So a lot of the time, children find it very easy to learn the first 5 prime numbers. 2, 3, 5, 7, 11. Say that a few times. Pause the video if you want to say 2, 3, 5, 7, 11 a few times. You'll probably learn it. And many children after that end up learning the first 10 because it goes 2, 3, 5, 7, 11. And then it goes 13, 17, 19, 23, 29. Prime numbers go on forever, of course. They just keep going. But those are the first 10 prime numbers. You notice that 1 is not in the list, of course.
You are the chosen one!
That's because 1 is the chosen one. And there's many other numbers that are not in the list, such as 4 and 6 and 9, because they have more than 2 factors. So the numbers we've looked at here are called the prime numbers, primes. The numbers that are not on this list, apart from the chosen one, of course, all the other numbers are called composite numbers. Composite numbers. So that's everything that's not prime except 1. So not 1, but 4, 6, 8, 9. What's the next one, Mr. Blom?
10.
10.
12. Or very simply as definition, it just has more than 2 factors. Any number that's in a multiple of 2 that's not a 2 has more than one factor, because the factors of 4 would have 1. It would have 2 as a factor. It would have 4. Did I say 4? 4 as a factor.
So we have the primes, we have the composites, and 1 is the chosen one.
Yeah. I'd say, just to remember composites, I tell my children to use the word composer to help you. If you're a composer, you need quite a few people playing their instruments. You can't just have 1 or 2 people. So a composite number is kind of like a composer. It needs more than 2 factors to be able to work. We started with multiples, and then we went on to factors. And without the understanding of multiples, you're going to struggle with factors. Without the understanding of factors, you're going to struggle with prime numbers. And without the understanding of prime numbers, you're going to not understand composite numbers. So it's that progression which is really important. Go back to the earlier videos if you're ever struggling. You will get to a point where you'll understand these progressively as you go on. Now I just want to introduce some new vocabulary called a prime factor. Now, I don't know if you remember in the past video, we looked at factors and factor pairs. When we were doing factor pairs, we were creating out a tree line. I don't know what even know what's called it. And I kind of created a visual aid to show us our factor pairs. So the way in which I'm going to do this now is very, very similar. Go on.
I think you call those factor trees.
Factor tree. There you go. Factor tree. So I'm going to give us a number. We're going to find all of the prime factors of that number. Okay. Now, what I usually find with children in terms of them struggling is whenever 2 concepts are put together, or whenever more than one thing is demanded of them. So you've got 2 things. You've got the task of making them prime, and you've got the task of identifying them as factors. Now, when you get asked to find prime factors, you're going to be asked to find prime numbers that are factors of a particular number. Now, it sounds more complicated than it is. Let's take the number 12, which we've used quite a lot. And I'm going to use my method now, because you can use any sort of method you want. You can use Mr. Sewell's. They are so similar. I'm going to create my little lollipop. I was going to say lollipop. Looks a bit like a lollipop, doesn't it? And I'm going to identify all my factors from 1 to 12. I'm going to go, okay, 1 goes in there, 2 goes in there, 3 goes in there. And then 4 is a factor pair of 3. 6 is a factor pair of 12. And obviously 12 is the factor pair of 1. Now once I've done that, I now go on to... So I've done the factors. I've done the first bit. It's telling me to find prime factors. Well, the first thing you do is actually find all the factors before you can make them... before you can identify them as... Before you can identify the prime numbers. Did you want to enter that?
Well, if you know that the first 5 prime numbers are 2, 3, 5, 7, 11, now you're going to be okay, I think.
Absolutely. And that's what, I mean, I recommend you do that, is if you are looking at a number like 12, there's no problem in writing down all the prime numbers that you know so far, especially when you've just learned it. So Mr. Sewell went over the first 5 very quickly, and it was very easy to identify. Was that 2, which was that weird even number that's a prime number. Then you've got 3, then you've got 5, then you've got 7, then you've got 11. Now I don't need to go any further, because obviously we know that 12 is not a prime number, because 12 is an even number. So I'm going to use those numbers and see if they just match up to any of the criteria that I've got over here. I'm going to start at 1. Remember, it's very easy to say that 1 is a prime number. It's not. It's definitely not, because it doesn't have 2 factors. 2, on the other hand, despite being an even number, does have only 2 factors. 3, absolutely. 4, definitely not. 6, definitely not. And 12. So if I'm answering this question, what I'm saying is that the 2 prime factors of 12 are 2 and 3. Let's go into another more complicated, maybe more reason-focused question that might look wordy. It might look to use maybe or confuse the children doing the question. But if you read it carefully, you will be able to understand this. It says multiply numbers to make 12. So we're going to make the number 12 only using... So that's number 12, only using prime factors. Now we know that the prime factors of 12 we've identified using the earlier method are 2 and 3. So we need to find out, how we can make that number 12. Well, we're lucky because we only have those 2 prime factors, and we've got 2 times 3, which equals 6. And if we have 6, we only need to multiply it. What number? 3 or 2 to make 12? Yes, you only need to multiply that 2 again to make 12. So therefore, if I multiply 2 by 3 or 3 by 2, it doesn't really matter, and you multiply by 2 again, you're making 12 by multiplying numbers using only prime factors. It's again being very conscious and careful. I'm gonna go over it. It's making sure you identify that you need to multiply numbers first. You need to make sure that you understand what number you need to make. And then the most important bit, and this is where you're going to be tested to having to ensure you know what a prime factor is that you need to identify which of those which numbers of 12 are in fact prime factors, so that you can make that 12 accurately.